Many of the technologies inside of the .NET framework make extensive use of inheritance. For example, here in our WPF application, we have a main window class, but it inherits from a base window class that's written as part of WPF. System.windows.window, you can see in the description here, provides the ability to create, configure, show, and manage the lifetime of windows and dialog boxes. We inherit all of those capabilities into our main window class. That's why we can put something onto the screen without writing a lot of code. All of that behavior is already built into our class, even though we don't directly see it here. But we can take advantage of things that are built in. For instance, that base class defines a title property that if we set it, it'll show up in the title bar of our window. And it's really easy to do that. We just set the property. We didn't have to do any of the things that we might have to do in Windows programming to get that done. It's a simple property set. Let's look at something else. Here, our employee, if I type e1 dot, you can see in the IntelliSense window we have these methods equals, get hashcode, get type, and toString. Where did they come from? They didn't come from our class definition. We just had a couple constructors and a name field. But remember, every class that you're writing in the .NET framework implicitly derives from system.object. So even if you don't specify that, it's implicit and it happens. Those members that we're seeing, such as toString and get hashcode, those are methods that are defined by system.object. We inherit those, and you'll see those available in every object that you write in .NET. Let's change direction just a little bit, and instead of putting text on the screen, let's actually put some colorful shapes on the screen, like squares and circles. If I want to draw a square, what I might start off with is a class that encapsulates the drawing of a square. It's going to have a draw method. And I need something to draw on when I'm inside of the draw method. In Windows Presentation Foundation, one way to do that is to use a canvas. Now, since we're going to require a canvas to draw on, I'm going to make it an argument to a constructor and force someone who's creating my square object to pass me in a canvas that I can draw on. And since I actually need a reference to this inside of the draw method, and not just in the constructor, I'm going to create a field called canvas and save a reference to this canvas inside of the constructor so I can use it inside of the draw method. But before we do that, how are we actually going to paint the lines and fill a square with colors? WPF can help us out there too, because it has a built-in rectangle class. And what I'll do inside of the constructor is instantiate that field to a new rectangle and set some properties so that it has a width of 10 pixels and a height of 10 pixels. It'll fill itself with a green color and have a black outline. Now I've completed the draw implementation for square, and you can see what I'm doing is I'm going out and calculating a left and a top position where I'm going to place this square on the canvas. And I'm doing that using a random number generator that's available in the .NET framework, the random class. Essentially, invoking the next double function will return a number between 0 and 1, and I'm going to use that as a percentage to multiply by the actual width and actual height to make sure it gets positioned somewhere on the canvas. The top left of the rectangle should be on the canvas somewhere. I'm going to set the value so that it appears in that place, and then to actually place it on the screen, I go up to the canvas and tell it to add this rectangle as a child object. So it's something the canvas is now responsible for. It's going to put on the screen. I've also implemented a circle class. And a circle class takes a canvas in the constructor. It has a draw method. And if you look at these two classes, there's a lot of similarities. The draw method, in fact, is exactly the same, except for the fact that one's working with an ellipse and the other one is working with a rectangle. Generally speaking, this is how I approach inheritance. If I have two classes that start getting a lot of duplicated code, I start looking to see if there should be an inheritance hierarchy somehow so we can share that code between the two classes. So instead of having a full implementation of draw inside of circle and inside of square, let's create a base shape class that both square and circle can inherit from. Now I've finished the implementation of the shape class, And you'll notice that it still has a constructor that requires a canvas because this is where we're going to do the drawing, and it still has the draw method that uses that canvas. All of that code that was duplicated in both the circle and the square class is now inside of shape. And our circle and our square now inherit from shape. These become very simple classes. They don't need to know about the details of drawing. That behavior is inherited. It's taken care of for us. All we need to do is focus on creating the type of square that we want. So we're still creating a rectangle and initializing it with specific colors and a width and a height. Back up here in the draw method, there is one subtle difference. Instead of working specifically with a WPF ellipse or a WPF rectangle, it's working with a UI element. This is one of the neat things that you can do with inheritance. I have a field here typed as UI element, and because rectangle and ellipse in WPF both ultimately inherit from UI element, I can treat them both as UI elements. So I don't need to worry if I'm specifically dealing with a rectangle or dealing with a ellipse. They're both UI elements. I'll give you another example of this in just a minute. Something else I want to point out is that there's a compiler error currently in my circle class. And the reason is this. When you're constructing a new circle, what the C# compiler does is set up the code to invoke the constructor of circle as well as one of the constructors of the shape class. Because remember, when we're constructing a circle, we're really constructing a shape too. We're inheriting all that stuff. It has to be initialized. There has to be a constructor invoked on the shape class too. And what the C# compiler is telling us is that when I'm constructing a circle, I don't know how to construct the shape. There's no constructor, there's no default constructor that takes 0 arguments. You have to tell me what constructor to invoke and give me some arguments, because this requires a canvas. And there's a special syntax for that in C#. What you do is, after the constructor method, you use the base keyword and then pass in any arguments that are required by your base class constructors. The sequence of events then when you say new circle is that the C# compiler will invoke the base class constructor first, and it'll do that by passing in this canvas, and so any initialization that needs to occur inside of the base class will occur, and then it will invoke the constructor that you've chosen for the derived class, in this case circle, and this code will execute, and at the end you'll have a fully initialized object that is a circle, and it has everything that it needs inherited from shape also. With the squares and circles in place, let's jump back into the loaded event for the main window and actually put something on the screen. We can construct a square and assign that to a variable of type square. We can construct a circle and assign that to a variable of type circle. We can also construct a circle and assign that to a variable of type shape. I'll show you why that's powerful in just a second, but remember, it's the shape class that defines the draw method. That means anything that is a shape will have a draw method, therefore we can walk up to S3 and invoke a draw method. Let me press F5 to run this real quick, and we should see 3 shapes appear on the screen, 1 square and 2 circles. That's perfect. Let me show you a couple things that you cannot do. I can treat a circle like a shape, and I can treat a square like a shape, but obviously I cannot treat a square like a circle. Those two types are not related, so the C# compiler will be unhappy there. But I can, of course, treat the square like a shape. Something else I wouldn't be able to do is, let's say that I had a custom method defined on my circle class. So let me add something here called compute circumference, and it doesn't actually do any real computation as yet, but what we'll see is, back here in the main window, S2 is typed as circle. So because that variable is typed as circle, the C# compiler will allow us to invoke compute circumference. Now, S3 is a circle. That's what we created there. But we typed that variable as a shape. So the C# compiler isn't going to treat that variable reference like it's pointing to a circle. It's going to treat it like a point to a shape. And the only method that we can have there is the draw method. We cannot invoke compute circumference. Now that might seem like a drawback, but there are many times when you want to treat objects through a base class reference. I showed you one when we constructed the base shape class here in that we wanted to treat WPF rectangles and WPF ellipses as UI elements because that allowed us to write generic code inside this draw method that could draw either. Another example would be, let's say that we wanted to put 100 shapes on the screen. What I could do is I could set up a loop. So this is looping for I equals 0 to I is less than 100, and then incrementing I each time the loop. This is going to run 100 times, and each time through the loop we'll draw two shapes. We'll draw a square and a circle. But both times I'm going to invoke the same method to actually get it on the screen, a method called drawShape. And inside of drawShape, we can draw any kind of shape. We can draw anything that inherits from that shape base class because we know it has a draw method. So when I run this again, then what I have is some very generic code that knows how to work with shapes and get things onto the screen for me.